Good day everyone, welcome to my workbench. So we have a laptop that is coming from another computer repair shop. You know, like what I said, most of the jobs which I'm fixing here, it's like already someone attempted to do something and they failed, they sent it here. So we have an Acer Aspire E1-531, that's the model. The laptop looks like this. If you are in Zimbabwe, you know this is the common most kind of laptop. They used to call this laptop Acer Police. Why? Because there was a credit company which was offering this kind of laptop model to civil servants on zero deposit. So during that time, it's like 6-7 years ago, during that time, a lot of civil servants got this laptop on credit from, what's the name? It's Creative company, something like, I can't remember the name, but it was like an explosion of this model of Acer laptops, and I fixed the main, trust me. So this is coming from another computer repair shop. The laptop came in open like this. It's open, I didn't check anything, but it's not powering on. According to what they said the laptop, okay, that's the laptop. According to what they are saying all the voltage is okay, but the laptop is not working. Let's see if that is true. We plug in the power supply and it's taking like 10-20 milliamps. Let's check the main 19 volts power line. We have some MOSFETs here in serial mode. That's the output of the second MOSFET, 19.5. Here we have an inductor here and some ceramic capacitor. I believe this is a power supply. Yeah, it is a power supply, 19.5. Here 19.5. Here we have another power supply here, 19.5. So the 19 volts power line is present. What is the next step is to check for 3.3. Here we have a switch connector. I'll check every pin. Pin number 10, number 20, number 30, number 40, number 50, number 6, number 7. So the 3.3 volts is missing. The next step, we have an ENE chip here and the BIOS chip. On pin number 8 of the BIOS, 0. We don't have voltage. On the ENE chip here, the EC chip, I can't see any voltage. So for sure this laptop is not powering on because the 3.3 volts power line is missing. So let's take the motherboard out. And try to identify the 5 volts and 3.3 volts power supply. We don't need the frame yet. That's the motherboard, and it seems as if someone once worked on this motherboard. They tried everything, but that's the motherboard. The motherboard looks like this. I can see here this area was once worked. And if I check on the other side, we have some flags. So let's go on a microscope. That's the motherboard. We have ENE chip. And check here. This looks like flags. This is the flags. Maybe they reflow the chip. Here we have another flux here. Okay. Here, this area, I think they also did something here. Here, I believe this is the 3.3 volts and 5 volts power supply. Because we have two coils, two output capacitors, 4 MOSFETs, and those ceramic capacitors in parallel mode. One side is 19 volts and the other side is ground, and we have an inductor here, PQ17. So this capacitor looks not to be in place. So this is the driver for this power supply. And the problem is we have some code here, EN, ED. We are not sure about the name of this driver. But let's check something. Let's check something. What I want to do is very simple. Let me look for the charging port, and then we check for some voltages there. I think we can. Power supply. I'll plug the power supply. What I want to do, I want to concentrate here, because from this chip we have the VREC 3 and VREC 5 from that chip. So let's check for 19. Here we have 19.5. We have 19.5. Here we have nothing. Here we have nothing. So what is the story here? Because this chip has to be we must have some voltages always on. The 19 is on. And I can't see any voltage. Yeah, we have the V in. You can see from this capacitor. From this capacitor is going to straight to this chip. So we have V in, but basically we don't have output. Any output, like the 3.3 always on and the 5 volts is missing. So I can say this chip is dead. But the problem is we don't know which chip is this one. Let me look for the schematics. Let me look for the schematics. If we can, Acer E1-531 motherboard schematics. Maybe we can find something on Google. Let's look for these schematics. Okay. I want schematics. Huh? That's what I want. Download successful. Let's check the schematics together. Downloads. Oh. We have to check these schematics to see if everything is okay here. Because why it's not opening? Yeah, it has opened. So that is schematics for Acer E1-531. We have the North Bridge, we have the ENE KB930, the BIOS chip. We need some power supplies. We need some power supplies because from there we can conclude a lot of things. Where are the power supplies? We see that the battery connector. You know, fixing schematics is very nice. Everything is written. We have the BTT, VCC, we have the clock and data, we have the minus pin. Okay. Everything is nice with the schematics. What is this chip? KB92. KB92. 9012. KB9012. Maybe we can draw. You see this chip? Where I'm underlining with the red line. That's the EC chip, ENE. And if we check on this chip, we have these 3 volts. This is 3 volts, is always on. And from these 3 volts, this pin number 9 of the EC chip, this voltage is generated by the VREG3 from that 3.3 and 5 volts driver, which we want to know. For we see the power on button, but that cannot be helpful because we want power supplies. Where are they? Power supplies. What is here? Yeah, you see that's the input circuit. So let's start here from the input circuit. We have the V in here. We have this MOSFET A04466L. This one. And here we have another MOSFET. So M1 and M2. These are MOSFET in serial mode, and the gates of the MOSFETs, like what we said, if you check these gates, they are going straight to the BQ chip. They are all going straight to the BQ chip, which is BQ24725. That's the mode of this BQ chip. And after the two MOSFET in serial mode, we have the current sensor, PR41, that's the current resistor, and also is sensing if there's over voltage or under voltage or over current. It's doing a lot of things, and is communicating with the BQ chip, and the BQ chip will send signal to the EC chip to cut down the power in case if there's anything wrong on the circuit board. Okay, so that's what this chip is doing. That current, this is the current sensor, which is around 0.5 to 0.9 ohms. Very low resistance to ground. Very low resistance, not to ground, but from one side to another side. It's like a fuse. That's how this thing is working. It's not going to ground, but from one side to another side, the resistance is very low. So after that, we have the ceramic capacitors. We have coil ceramic capacitors connected to 19 volts, and we have those MOSFETs, which are also the gates. They are going to the BQ chip. The gates of this MOSFET, they are going to the BQ chip. After that, we have coil. We have another current resistor here, which is managing the battery. Like when you have over voltage, under voltage, this current is also communicating with the BQ chip. That's where you see those some kind of weird errors on the battery. Plugged in, not charging, plugged in, charging 100%. When you unplug the charger, the laptop shut down, because this current sensor is communicating with the BQ chip. If anything is wrong on the battery side, otherwise the battery won't charge. Here we have the B+, the minus, and some clock and data, and the power from the battery is coming from this direction. We have MOSFET, which is 3 pins together, that is source, 4 pins together, drain is also going to the VCC, and from this point is going everywhere. So that's the input circuit. These are N-channel MOSFETs based on the last number, which is 6. It's an even number. So what we want here, we don't have problem because we have 19 volts. Our problem is from this chip. Let me make this bigger. Our problem is from this chip. If you look at this chip, this is RT8005. And this chip, what it is doing, I explained this thing many times. This is working like 51225, 511, 1225C, a lot of drivers which are generating 4 outputs there. We have these 3 volts, which is always on. You think your laptop is off, but it's not. This 3.3 volts is always on. That's number 1. Number 2, we have the 5 volts always on. So we checked on that chip. We don't have all these voltages, but we have the V in. Where is the V in? V in here. We do have pin number 15 with this capacitor. We checked on this capacitor. There was 19 volts on this capacitor, but no outputs. And if we check closely on this chip, we have VREC 5, which is the third output. Very low output power supply, around 175 milliamps. Here we have the VREC 3, and here this is very important, both from the VREC 3 pin number 8 our startup chip is getting power. So if this chip has V in but no outputs, I assume that we have a dead we have a dead EC chip here. So let's try to replace this chip, because from pin number 8 our EC chip is getting power. So the problem, they checked all the power supply, the F19. You see the laptop charger is 19 volts. You think the laptop is only working with 19 volts. That's not it. We have 3.3 volts, we have 5 volts, we have 1.5 for the RAM voltage, we have 1 volt for the processor, we have many voltages there. So our problem, I think this chip is dead because we don't have output. So let's go and see what we can do on this chip. Let's see what we can do here. Because we need to replace this chip. I think this is the common chip, RT8205. I think we have many. Last time, if I do remember, that's the one. We have like so many chips here. That's another one. So we are safe. And chip position is like that. So we are safe here. So let's take down this chip and replace it. Okay, let's replace the chip now. That capacitor is not looking good. So the 3.3 is missing because the chip is faulty. All pins are fine here. Now we need to cool down the chip. Let's cool down this chip. Let's cool down this chip. I think we can test. What do you think? I think we can test. We can test here. So where's the frame? Let's see if that was the problem. Let's see. Oh, I forgot to check some voltages. But let's put the motherboard and test once. I'm supposed to test first, just for the sake of not doing same job twice. I want to test. That's what I want here. Let's plug the power supply, and it's now taking 11 milliamps. That's an improvement. It's now taking 11 milliamps from 10 to 20 milliamps. So let's check same test point which we tested before. Here, Y18. Y18. Last pin of the BIOS, still we don't have 3.3 on EC chip. .37. You see on the screen, we now have voltage. If I check on the switch connector, we now have 3.22. So let's try to power on this board with a tweezer. I'm not sure which pin to short here. Pin number 2 to ground, and it's working. We don't have picture. Come on. We have picture. You see? No boot device because there's no hard drive. The hard drive is missing. And we now have 834 milliamps. So it's working. It's working. So that was the problem. Where's that chip? Where's that chip? This one. Maybe you can't see, but this chip was the problem. RT 8205 driver. The laptop is on. We still have a working laptop here. The laptop came like this. So what I have to do, I have to give back to the computer repair shop. They put everything together. So maybe they did something, they burned up the chip, and the chip was not outputting any voltage. So if we have this kind of problem, we have 19 volts, but we don't have 3.3, and the chip, we only have, you have like codes. Please just try to look for the schematics just to know what kind of driver you are dealing with, so that you replace with the right driver. So what I can say, like, subscribe, don't forget to turn on the notification bell for future updates. Also share our videos for your beloved friends and relatives. Yeah, that was a nice cool repair, and we still have light here. You can see the LED. We still have a blue light. So we still have a blue light, and the screen is still on. So see you on the next one. Bye.